Hello ladies and gentlemen, what's up? It's Papa Bale. Welcome to the channel. Hit the like, subscribe, join up. We're all good here. Alright, so what we're doing here is we're generating some eddy currents and we're trying to measure them to the best of our ability with what we have. From what I gather, we're not going to get very much out of this, but we're going to get something. And so let me break it down. We got an SSG drive on the bottom, 4 magnets on the bottom, all north facing out. And then we're only going to be using the bottom rotor for this experiment, since it has the most profound effect on the aluminum disc. It's yoked by the aluminum disc. The aluminum disc is 1/4 inch, 6 inches in diameter. The pickup coil is 1500 turns of 32 gauge with roughly 1.5 to 2 inch center hole. So it only goes around the edge of that. If you can't see, it's about 2 inches in the middle there. Okay, so I'm going to turn it on. We're spinning the bottom rotor this way, counterclockwise. .75 volts in. See, all I need is that little flick. Okay, let's turn on music. Turn on the scope. And make that as big as it can be. Alright, there's our eddy currents. Very small reading, about looks like 2.0 to 2.7 volts. Right around 2 volts. 2.2 volts. Really neat. And that's the AC, what we're getting off of the coil. So this is where the multimeter is hooked up, right here. And then in order to get the DC version of the whole thing, see, and we're not getting any voltage like buildup in the capacitors here. Only when we run the top one do we get a bunch for this. And that, see, it's more magnetic induction with the top one than it is with the one on the bottom. This is eddy currents. But I kind of want to see what this looks like with the top one engaged. So I'm going to turn that up to 9. And I'm going to spin it clockwise. You gotta back it out. So you get a bunch of the induction waves, the sine wave style stuff, and not the current vibration. And you see we're getting like 21 volts now. So we're gonna cut off the top one. We'll watch the wave dissipate. See, it looks like you can see the eddy currents kind of riding that wave. Sweet, dude. That is so cool. Back it out one. There, look at that. And our lights are lighting up and everything else because the magnetic induction is, I guess, more intense. I don't know. I can't explain the difference, but you can see it. You can see the difference. So cool. And then I guess we could get an entirely different wave if we then connect the two ends of the coil together with the diode. Then it changes yet again. Maybe we should try that real quick. Alright, I'll be right back. Alright, we are back and the diode is in place and our wave is significantly different. It no longer dips down, which is expected normally when putting a rectifier in the line. But we got it hooked up to the rectifier, and we got it hooked up to this apparatus, the scrubber. We got it hooked up to the multimeter. And I believe these little excited blips per cycle would be eddy currents. Perfect. And like echo, you can see it echoing. It's awesome. Alright, and that's with the Schottky diode in there. I have a regular rectifier that I can use. It's 1,003 amps, 1,000 volts, 3 amps. This is 45 volts and 15 amps. Don't know if that's... I'm pretty sure it'll work. I don't know if it'll change the wave at all. But adding the rectifier or Schottky diode definitely changed our wave. Very cool. Here, let me check our voltage rating. So very low voltage. Very low voltage. I believe our wave spikes peak to peak on the scope here are like 1.9, 1.7 volts, and that's probably right around where we are, considering how mismatched the coil is to the magnet and everything else. It's pretty good for the disc size though. Goes all the way to the center, hangs out a little bit. So yeah, man, this is great. I think it's great. I mean, it's a very low number, but that's obvious. It's an obvious reading there that is not your typical magnetic induction reading. And it's connected to itself. This coil is not connected to the drive in any way, which I would have been thinking next. Here, let me turn this off, and we'll get a load of the reading as it turns itself. Okay, so obviously it is in correlation with the power, the electromagnet, more so than the other ones. Look at that though. You know, I wouldn't think that it had to do with the magnetic induction, and it doesn't. It's more of the electromagnetic field hitting the aluminum disc than it is anything else. Because it's the only thing that's actually probably close enough hitting it. The permanent magnets aren't close enough for the field to grind on the aluminum. But this, it's touching the aluminum. I'm probably overlapping quite a bit. And that was kind of sticky right there. All right. Thank you very much, ladies and gentlemen. Peace out. Have a wonderful day. Bye now.